Hello, my name is Ondřej Vaculín and I'm professor at Technical University of Ingolstadt in Germany and its associated research center for automotive safety called Charisma. Today I will talk about the protection of vulnerable road users with crash avoidance systems. But first, let me localize the topic with the driving states. If we have a look at different driving situations on the roads, one can define four basic states from the safety point of view. In the normal driving, which is indicated as safe driving on this slide, the most important role plays the active safety, such as brakes or steering, assisted by assistance systems, for instance, to keep the vehicle in the center of the lane. Next, one can come to a dangerous situation. These are usually situations in which the driver loses control of the vehicle. Her or his current capabilities are lower than the demands of the situation. In such a case, we can distinguish the phase in which we can avoid the accident or at least to mitigate its severity, so-called crash avoidance in this figure. In this case, the advanced driver assistance systems immediately intervene to the vehicle controls. Further, if the accident is not avoidable, the passive safety measures should reduce the severity of the accident. And after the accident, so-called post-crash measures should help to rescue the accident participants easily. In this presentation, we will focus on the crash avoidance related to the vulnerable road users. Who are the vulnerable road users? Among the vulnerable road users, or abbreviated to VRUs, we count pedestrians, users of micromobility devices, such as bicycles, pedelecs, e-bikes, e-scooters, and so on. And last but not least, the users of powered two-wheelers. These are motorbike drivers, scooter drivers. Majority of accidents is caused by the human mistakes. The statistics talk about 90 to 98% of all accidents. The rest are technical or other issues. Very often the accidents are caused by distraction. Many drivers do give more attention to their mobile phones, for instance, than to monitoring of the traffic situation. The role of advanced driver assistance systems is to mitigate the human errors, either by avoiding the accidents or by mitigating of the accident severity if the accident is not avoidable. The advanced driver assistance systems can help the driver, but he cannot rely on them. The driver is still responsible for the driving and also for the accident. Since the advanced driver assistance systems contribute to traffic safety, in some regions they are becoming mandatory. On the graph we can see some prediction of the penetration of the ADAS systems in the different regions. e.g. in Europe, they will be required by the legislation. That's the reason why we have 2025 100%. Here we have some examples of advanced driver assistance systems which should mitigate the human errors with vulnerable road users. The first one is the front assist. Front assist automatically brakes before an obstacle, such as pedestrian or cyclist, for instance. Next one is the side assist, or we can call it also lane change assist. In the case that the driver is going to change a lane, he gets a warning of a vehicle for instance a motorbike, in the blind spot of his mirror. The third one is the door opening warning. Warning when opening the door if a vehicle or cyclist is approaching to us. And last but not least, we have the rear maneuver assist, which brakes the vehicle in the event that there is an obstacle when reversing. What are the typical interventions? Actually, we have seen two basic. Either the driver gets a warning by some acoustical, haptic, or optical information, or in the second case, the vehicle intervenes to the driving, for instance by activating emergency braking. What are the main functional blocks of the ADAS systems? First, we should observe the surrounding, and for that we use some sensors. So this is the block called perception. Second, we have the block called decision making, in which the effective algorithms do propose some solution. And at the end, we should implement this solution by actuators to the vehicle hardware. This slide presents the typical setup of sensors for the advanced driver assistance systems. What we can see are the ultrasonic sensors for short-range identification of obstacles, usually supported with 4 cameras to get a bird-eye view. Furthermore, we have for short and mid-range the radars in the corner of the vehicle, and for long range we have in the front of the vehicle a radar and a camera. Let me to present shortly the typical requirements on design of vehicle. And we can have such a triangle. On the top there are the mandatory requirements, then there are some standards which are usually not mandatory, recommendations. Further, we have the consumer testing organizations. This is for instance Euro NCAP or other NCAPs which are listed here in the slide. And then we have at the bottom are the internal requirements of the OEMs. From the point of view of the advanced driver assistance systems to mitigate the collisions with pedestrians and other vulnerable road users, there is already some legislation. This is the General Safety Regulation being now valid since 2022 and bringing in a couple of phases the requirements for the systems. And for the testing, this General Safety Regulations refers to the UNECE Regulation 152 in the case of vulnerable road user protection. So now let me to present some video from testing, and this is from Toyota Corolla Cross. The test has been performed 2022, and we will see some typical situations for the advanced driver assistance systems for vulnerable road users. First of all, we have the pedestrian walking along the street, and the vehicle is able to stop in both situations, day and night. Then we have the so-called far side pedestrian coming from the far side. This is the near side at night. This is the crossing junction, Then the vehicle must stop and let the pedestrian cross. This is a child coming from some occlusion. Then we have here cyclists running in front of us. We have cyclists coming from occlusion, near side. And this is again the cyclist from another view. So So let's keep the same vehicle as in the previous video. Here I would like to present the results of Toyota Corolla Cross. What are from Euro NCAP? It's coming with 5 stars. And here we should mention that Euro NCAP is rating vehicles with stars. It's different to the type approval. In the type approval we have just pass or fail. Let me to present you some examples of experiments of tests to validate the advanced driver assistance systems for pedestrians. In this case, on this slide, we have on the first line, we have the pedestrian crossing the road, so-called far side pedestrian. We have near side pedestrian, again crossing the road. The vehicle in both cases is running from 10 to 60 kilometers per hour. The step is 5 kilometers per hour. You see that the testing is very extensive. We have experiments with child jumping to the road, being occluded by parked cars, or pedestrian going along the road. The next slide continues with the tests required by Euro NCAP, with reverse driving, and also that what we have seen in the video with the junction, with the crossing and the pedestrians crossing the road. Now we are coming to some examples on cyclists. You see that the examples are very similar to the cases we had with the pedestrians. This is just some samples, not all. Just the speed of the bicycle is different. So we're talking here about 20 kilometers per hour or 15 kilometers per hour. And it results to slightly different requirements for the systems to recognize the pedestrian and to act. Last one is the warning for door opening, which I have already also mentioned before. And now again coming to some examples. The full list is then available to Euro NCAP or another sources. For the so-called PTW, it means powered two-wheelers. And in this case, again, the first one is similar to those we have previously seen. However, the speed range is slightly different. And then we have also somehow the systems taking care about the emergency lane keeping if a motorbike is running in front of us or if the motorbike is going to overtake us. Just to show you that not every experiment could finish in a positive way, I would like to present you another video. You see some experiments we have seen before, we were discussing. This is the near side in daylight, near side in the night. Then we will come to a child, and in this case we have an accident. So, but the targets, so-called soft crash targets, are designed in such a way that they don't destroy the vehicle, and they also are possible to be fastly built together and prepared for the next experiment. The targets should have the visual, radar and LiDAR features of a human body. This is another experiment with the along driving bicyclists, and there will be the next one with crossing bicyclists. You see that this works fine. This is crossing bicyclists with an occlusion, and in this case we can indicate that the system reacted too late. But the systems are being designed for those tests, and if we go for some non-standard testing, as for instance here with non-standard speeds and non-standard distances, Or here in this case with non-standard environment, this is a typical environment in which we have a lot of reflections, or some different types of road users. In this case it's a micromobility user. The system cannot react as expected, and this is the reason why I mentioned at the beginning the driver is still responsible. He cannot rely on the system. He must the system let support him but not let to drive the vehicle. Now we are coming to the conclusion of this presentation. We wanted to share some information about the protection of vulnerable road users with crash avoidance systems, or if we want, with advanced driver assistance systems. We can say that the advanced driver assistance systems with functions to protect vulnerable road users do have an important contribution for the reduction of accidents with the vulnerable road users. The accidents are often used or caused by driver mistakes. For instance, driver distraction, playing with the mobile phone instead of driving. The systems are just assistance systems. It means I cannot play with my mobile phone even if I have all the systems in the car. This can be done later on in automated driving with higher levels. It means that assistance systems, I cannot rely on them. I should keep the responsibility for safe driving as a driver. The advanced driver assistance systems, nevertheless, do have big potential to avoid the accidents or mitigate the impact by reducing the impact velocity. What means that the severity of the accident will be probably lower. In Europe, the systems are being tested by the consumer testing organization EuroNCAP since 2016, and now next year are becoming mandatory for all new models, and from 2026 for all sold vehicles in the European community. So then we are at the end of the presentation. I would like to thank you very much for your attention, and for the case that you have any questions, so don't hesitate. This is my email address, and send me some email. Thank you very much and have a nice day. Bye bye.